Good day. It's Tuesday, June the 22nd. I'm Martin Gagel with Market Radius Research. Today we're joined by Sue Ozdemir CEO and John Meekison CFO of EXRO. EXRO is a clean tech company developing and commercializing products to increase the efficiency of electric motors and battery systems. Sue and John, thank you very much for taking the time to meet with us. That's really good. How are you guys doing?
Fantastic. Thanks for having us, Martin.
We're great. Thank you, Martin.
All right. So, yeah, it's been a while since we've chatted. I guess just a bit of a background. I view myself at EXRO as being a friendly company. I've known them when since they were pre-public days and seen the evolution over the years, although it's been a while since we've chatted. Sue, so it's great to get an update on how things are progressing here. So why don't we walk through the deck here? Take it away, Sue.
Okay, perfect. Thank you. So for those of you that don't know about EXRO, we are really pioneering a new type of intelligent electrification. We are specialists in power electronics, which means that we build the controls for motors, batteries, generators. All of our technology is patented. Our current headquarters is in Calgary, Alberta, where we have a research and development innovation center and our new production facility. And I'm currently here in the US scouting for our new USA headquarters. What we really do is optimize the power within a motor and a control or a motor battery, and we do that through that next generation power electronics. And the reason I like to refer to it as next generation power electronics is because as this electrification transition is happening all around us, you know, people are using what's available in the market, what's been available in the market, but what we're really doing is bringing to market what they'll need to really make that transition in a cost-effective, performance optimizing platform. So as you think about EXRO, what we've been talking about over the past 30 days since we released our new battery control system results is really our new footprint as we really focus on that dynamic power and the static power. So we're really formulating two different business functions where we have dynamic power through our coil driver and the ability to convert energy. Our main target market for that is really the mobility industry. So anything on land that moves from a golf cart to a electric bus, but also you could see us in the future go into renewable, like a wind application for generators, or maybe a mining application where they have that need for varying torque. And then our static power division will be our battery control under EXRO Energy, and that's really taking a synergy with that ability to go to the core of the soul of a piece of equipment and control it through the power electronics. If you think about those markets, I mean, the demand for electrification is huge, and it doesn't matter where you go. If you turn on your TV, your radio, you step out to your grocery store, everything from your fridge to your car seems to be going with some type of new sensor and electrification. And so as we look to that market, what we like to do is make sure everybody kind of understands our target markets. So on our coil drivers, which is our inverter product, the addressable market is over 7 billion forecasted by 2025, and that's inverters specific for vehicle use. If we look at all inverters for the entire segment, that would be close to 26 billion by 2025. And then from the static side on the EXRO Energy, where we're looking at battery energy storage, stationary energy storage systems, we're looking at a market of up to $30 billion by 2025, and that's with second life. And I'll talk more about our ability to use first and second life batteries as we move through. So I'm going to focus a little bit on our coil driver, which has been our launch product that we've been really focused on over the last year. On the screen, for those that can see it, we have our new coil driver for our 800 volts. You can see our connection points there with 12 connection points. That's a big part of what we do and how we access to the coil pack of the motor. As you think about our coil driver, you should really think again about that intelligent electrification. An inverter is the ability to, to control as the brain for a unit. So it's converting that DC energy from the battery into AC energy for the motor. Every electric vehicle in the market today has an inverter as long as it has a motor. So if there's a motor, there's a brain that's telling that motor how to behave. Our coil driver is a new type of inverter. So really what we're doing is replacing the existing inverters and the existing inverter technology in the market to now electrically gear and expand motor capabilities.
So,
if you think Yes.
Sorry, just to interrupt there. Well, as the inverter, there are AC motors and DC motors, because on a battery system, you're taking a DC coming out of the battery system and turning into AC for the AC motor. But some, like I think the Tesla 3 is a DC motor driven. Do you need it for like a DC motor? Is that a significant share of the market?
Yep. So DC is the AC is the bigger share of the market right now. I believe I'd have to check that one, but it doesn't matter which one. We can convert with both of them. So the inverter can be set to do either one. So we're agnostic to the type of motor that we're doing. We can do permanent magnet DC. Tesla uses a combination of AC induction and DC permanent magnet. They have 3 motors, so there's I think an induction in the front and then the DC in the back.
Okay.
So really, from the coil driver perspective, the coil driver is a trademark name that we came to name our inverter. And the reason that we named it that is that it's based on the concept of coil switching for electric motors, which enables a motor to have a greater depth of control. What we're doing is taking that physics and applying it to the electronics. So we're gearing or controlling through the electronic. And then we're driving. We're driving that command to the motor. We're telling that motor how to behave. And that's what an inverter really does. So as you think about a coil driver, you think about that ability to control the torque dynamically. That's never been done before. The ability to, on the fly, tell a motor how to behave, to respond to, I'm driving fast down the highway, or I'm driving, stopping and starting through the city, or I'm doing a hill. And because of that, I'm going to need a different combination of torque and speed. Or Martin, you and I would drive differently. So our driving dynamic would be different. So that ability to torque switch is really why we say we're the transition to electrification, because we're really thinking of the application that is the here, now, and future.
And Sue, with sorry to interrupt again.
No, not at all.
You can't, would your inverter provide benefits to any electric motor, or does it have to be one that's been sort of adapted so it allows for coil switching along the way?
Yeah, so it does need to be adapted for the inverter, not for the coil switching. So it doesn't need a rewind of the motor itself, but we need those leads to come out. So if you were to pop open a current motor drive package in an electric vehicle, you'd see 3 big motor leads coming out of the motor and into the inverter. We need 12. And the reason we need 12 is, or we can do 9, 12, but we need more than 3. We need access to every phase of that motor. So it is a small change that the motor manufacturers have to do. It does require some partnerships for us to be able to do that, but it doesn't involve additional cost or heavy weight on the motor manufacturers themselves.
All right, thanks.
Okay, so as you think about that brains and how we're regulating the power, just a quick kind of electric powertrain for dummies. We have 5 key components that convert energy in a powertrain. You've got your battery, your inverter, your motor, sometimes a gearbox, and then you push power to the wheels. You turn those wheels. Same thing when you use an EXRO driver. The difference is, instead of that classic inverter that you'll get from the incumbents, you're going to use our inverter, which allows you to do what we call optimize the motor, which means you're going to use a smaller motor in most cases, reducing cost, size, and weight. And you're going to optimize your gearbox. In most cases, we eliminate the need for 2-speed gearboxes because we do that switching through the electronics. And then you're still going to do the same thing otherwise. You're still going to control the powertrain the same as the classic inverter. So this is truly a new inverter to market with our tech incorporated into it. This is really a problem like we kind of touched on in the beginning, because currently manufacturers are racing to get product to market. They need to get that full vehicle, that new truck, that new car out to the market. So they're using what's available. And what's available means that they're controlling with 2 or more motors. We see everything up to the new Ford Mach racing car has 7 motors in it. It's the most motors I've seen. Tesla uses 3. The Porsche Taycan uses 2 motors and 2 gearboxes. And so really what they're doing is try to balance that need for city driving, where you have torque, you're stopping and starting, stopping and starting. So you're pulling a big heavy vehicle to start up, and then you're coming to a stop, start up and coming. Against that highway driving, where you're just cruising and you want to do full speed and you want to go fast and you want to get there. So as we think about that and we think about motors, the ability to be dynamic and respond to that is really why our controller is so important. We've done a bunch of simulations, and our simulations, our ability, it's our engineering team sandbox where they're able to go in and simulate. We use ANSYS, which is an industry standard top of the line simulation program. We take motor data with our drives and we look at that exact scenario. Our simulations are over 90% and usually over 95% accurate to our test bench results. And you can see this one here, we did a highway example. So taking the example of a supercar, a car that wants to go fast. And you can see we can increase speed and torque by over 30%. We've got, the ability to increase your kilowatt ratings by over 100%. So just a very powerful dynamic if you want to go fast. If you want to make one of those quickest cars in the world, using our driver would be able to optimize your powertrain. Now we flip it to a commercial truck example, and we compare it to some of the highest product currently available on the market for motors and drives. And you can see a huge improvement in torque and in speed, depending on what you're looking for. And then, of course, as we look to commercialize the product, being able to get into those major automotives and tier one suppliers means that cost matters. There's never a situation where you're dealing with an OEM for an automotive piece of equipment that cost isn't one of the first things that they're talking about. And as we think about electrification, it's even more important, because if we really want the world to transition to electric vehicles, we have to make it cost effective for businesses to do that. So as you look at ours, really our customers have two choices that sit in our value proposition. If they're looking to maintain their performance, they're happy with what they're getting, it suits their market, they can keep that same performance, but reduce the cost of the powertrain by over 20. And that's driven by a much smaller motor, because we're doing a lot of work through the brain, through the inverter. But if we have a situation like a garbage truck, where they're trying to pull more performance, they need to get more routes picked up, they need to cover more gradability, a little bit more cost would make a huge difference. Or if we think about logging trucks in northern Alberta, where currently they're buying 2 trucks to replace 1 diesel truck, the ability to pull more weight would be very important. So when we're thinking about performance, we can increase performance by over 50% with a cost of about 8% higher than what they currently pay today. And that's just build up a bill of material inside of our parts. So we have a very flexible system where we can look at performance or we can look at cost.
Sue,
yeah,
I would think that, let's say a motorcycle versus a garbage truck or a lumber truck, your biggest value will be in that higher demand, bigger power systems where they're as opposed to, would that be broadly speaking?
Yeah, I think that would be fair. The more we can optimize, the more we can make an impact on the motor, or reduce a 2-speed gearbox, or allow the manufacturer to use a smaller battery, the more impact we have on that cost position.
All right.
So really, again, as we've been kind of discussing as we went, just imagine driving up that hill, or imagine a garbage truck that can now pick up an extra route, or a race car that can have the fastest quarter mile, or a UPS truck that can now have multiple routes. Right now, they can only drive 1 route because that dictates how much charge they're going to get out of it. Now you're going to go farther on that single charge. You may be able to do a route with hills, not just a straight hill. So we're opening up new opportunities for all the fleet operators globally. We standardized, and we're working to standardize and have these products to market as standard product by the end of the year. We're working on the 100, 400, and 800, which falls into our low and high voltage. So it basically shows you the scalability. We can go from a small e-bike up to trucks and buses and high performance cars. And you can see that we have operational going out. Our e-bikes were out last year. Now we're working on our electric high duty motorcycles with Zero. We're working through our fleet delivery trucks with C Electric and Vicinity. We're working through our larger buses and trucks with C Electric, and of course our new partnership with Linamar falls into the high voltage, but we could also see some low voltage product there. As we transition, as we think about our new static control division, our new battery energy systems, really it was a synergy to that ability to control something and be the brain of the system. And as we look to the stationary storage unit, our team was especially passionate about the thought that with this great demand for electrification is a great demand for lithium ion batteries. And well, it's unanimously said from everybody right now that there won't be enough lithium ion batteries to serve the electrification movement. We also thought that there would be a lot in landfills, a lot that we wanted to participate in that recycling. So it's a little bit of a longer term for us. But in the meantime, we can fill these orders with anything from a first life application as well. So we could use a first life battery as well. So our new battery control system is really the cell level control of a battery energy storage system. So if we think about stationary energy storage to the grid, we're using that synergy of the ability to be the brain. And we're saying we can now control to the cell level, not to the module, not to the pack, but to the cell. This brings a whole new advanced level of control over a stationary energy storage unit. The foundation of our stationary storage unit is the ability to repurpose a battery. And the reason for that is if we think about a repurposed battery, it means that you're going to have degradation. So a UPS truck has been on the road for 5 years. The battery is now at a level that's deemed not usable, but it still has a lot of life in it. You can put it into our unit. It will test integral into the unit, and we can now use it to power streetlights, to power hospitals, to power commercial buildings. So it's enabling a new solution. We could also use a straight factory-made battery for first life and be cost effective. So just like we feel like we're a new brain for the energy storage and mobility industry, we're really a new brain for energy storage as well. So it goes deeper. Yes.
Is there commonalities in the technology between the coil driver and the battery control systems, or are they kind of independent technology types?
There is a synergy, yes, in how we're doing it. And the ability to use them together would require our next level of R&D. So we can use them as far as we can repurpose the battery, but right now we don't use our battery control system in mobility applications. So we're not putting this in cars or trucks from an energy storage unit. We're doing it to use those batteries from the trucks, but not as a controller.
But I guess you're indicating that that could be whatever, I don't know, generation 2 or 3, something like that, that's on you, let's say your product roadmap?
Yes, I would say that would be like a generation 3 on our product roadmap. We're working through some upgrades with different things that improve our product line for Gen 2. But for Gen 3, I would say that would be the combination of what we could do with our BCS and our coil driver together.
All right.
And when you think about a full energy storage unit, so again, we're not supplying what's just called the rack or just the controller. If you think about a stationary energy storage unit today, like a mega wall, a mega pack with Tesla, what you're going to see is all these components that are inside that container. When you use our inverter, what we're really doing is combining the power electronics inside of it. So we're eliminating the need for a separate BMS or battery management system and an inverter, which is normally in a system, and we're combining it all into EXRO's new BCS. So we're controlling, not managing. And you can see it's a much cleaner layout. We have much better control. And again, it goes right down to the cell. In today's marketplace, if a battery was to come out of a bus, what would have to happen according to North American standards is they would have to send that battery out to a center where a center grades it and says this battery is suitable for use in stationary storage, and then sends it out to a packager. With EXRO's unit, the truck manufacturer or the car manufacturer could send that battery directly to us. Right now, we're working with lithium ion phosphate prismatic cells. Again, we're agnostic to the cells, but that's our first pilot, and that's what we're working with. So let's say a lithium ion battery comes out of a vehicle, they could send it right to EXRO station. We would put it directly into our stationary storage unit, and it would test in the unit itself. So we're eliminating a whole level of testing. And then it would go right to the cell level, allowing things like swapping of batteries so that you can swap out that cell. It has a huge amount of state of health and state of charge benefits. So again, just to break it down, go ahead.
Okay. And I don't know if we'll get this later in sort of the business model. Is this part of, for the battery control systems, would you just be selling or licensing out the technology, or would you be actually part of the recycling system where you have a factory where you take in the old cells, you reconfigure them, test them, and then you're actually shipping battery systems with your control units to your clients?
Yeah, as we launch the business, we're going to finish developing the product for this year. We'll launch the business kind of towards the end of the year to beginning of next year. And right now, our thought is that we will supply the entire energy storage unit. And the reason for that is beyond our IP and the controllers, there's a lot of novel ways that we're doing the packaging that we feel we can really be a market leader for the stationary energy storage unit itself. And so we want to try to keep that close to EXRO and really take the market with what we can do. We're going to focus our targets on the industrial commercial energy storage markets, not on the residential or utility. We could do both ends, but our focus will be starting with that commercial industrial. And the reason for that is if we think about the ability to repurpose a battery, it drives down the cost of an energy storage unit substantially. And that's the target market that really needs that. If we think about a hospital or a Walmart or a new Amazon facility or a data center, those are areas where they really need that cost driven down. And so we think we're bringing a solution to a problem that exists in that market today. And we call it our battery control system. Again, everybody always, kind of refers to that battery management system. We purposely use battery control because we're controlling to a greater depth than what's currently in the market by going to a cell. And it's a system because it's a combination, really. It's an inverter to control the battery cells. That inverter has a user interface that allows that user to see state of health and state of charge in real time to the cell level. And it's next generation as far as the whole packaging system goes. So you can't just drop this into a normal unit and get the same results. And so to be able to get all the benefits of it, we're controlling that entire ecosystem. We won't package in-house. We'll contract out our packaging, but it will be a design owned by EXRO. And really, when you think about cell control, that means you're getting better costs. You're improving your power density, your kilowatt hours inside the energy storage unit. You're really improving the reliability because now operators can detect the thermal runway right to the cell level and can make choices of when they want to swap out, when they're going to do that shutdown. If you think about a mining site out in the middle of nowhere, that ability to know to the cell level what's happening makes a really big difference. And it's really important as we think about this transition to electrification and the demand for electric vehicles, there's not a lot of batteries coming out repurposed today, but in 3 years, that's going to be a drastically different picture. And only recycling isn't the answer. If we think about everything we've learned over the past 20 years, it's reuse, recycle. It's not recycle first. It's try to reuse that product first. And that's really where we're going. Again, if you imagine 10 buses, just 10 buses have enough battery power to power an entire office building. So as we think about how important it is that we repurpose these batteries, it relates all end to end into that entire infrastructure. But also from that mining site, that ability to know when your battery is going down so you don't have to move your entire energy storage system. And I think that creating a source of energy from discarded batteries is really important as we move forward. Again, we can use a first life battery. We could buy from any of the major battery suppliers today to serve the market as we build our pipeline. We're focusing on our 25 kilowatt and larger for our first launches. We've launched our proof of concept on our 25 kilowatt, which is a working pilot in our Calgary office. And we're working now through to build that up to our 1 megawatt. We'll have it done by the end of this year as far as a working proof of concept. In parallel, we're working through our UL and CSA approvals, which we hope to have done end of this year through the first quarter of next year. As you think about EXRO, what we really want to now kind of send out the message is that we are bringing these two innovative solutions together to become the next generation of power electronics for the market. And really our coil driver and our battery control system allows us to offer innovative next generation technology from end to end, from first life mobility applications to stationary storage applications. As you think about our roadmap to commercialization, we have 4 key partners that we deal with. We've identified these 4 key partners so our shareholders and our potential shareholders can identify with the type of partners that we're working with. And they're pretty straightforward. A development partner is somebody, maybe a new application that we haven't worked with in the past, a mining application or a new type of vehicle or something we haven't done that we're not really sure what the end result is going to be, but we think there's something there to develop. Our commercial partners are customers that have volume and established orders where we can participate in their supply chain after we validate our products. Our strategic partners are somebody like our new Linamar partnership that we announced this week, where it's a tier 1 automotive or an automotive manufacturer that has existing relationships, high volume contracts and licensing, where we start with a strategic development that allows us to build a product that we co-market or that we supply to them. And our motor partners are companies that are giving us motors, as we talked about at the beginning of the presentation, that give us motors that allow us to go faster to market and have a motor that's optimized for our drive. Our partner model today encompasses a list of about 10 different partners. We haven't updated this one with Linamar yet, but Linamar, of course, is our newest partnership announced this week. And we can see that we've got everything kind of in that validation stage right now. And what the different stages mean, that's where I'll focus, is our design stage is really where we've worked closely with a partner. We've taken our simulations to an actual concept design. We've now put it on a test bench, and we're giving that to the customer. Our validation starts from our test bench. So that's where we are with most of our customers right now, where we validate and send a message saying, this product is working on our test bench. And we flip it to the customer, who goes into their development side now, where they work for many months to validate not only on a test bench, but in actual operational applications. And as we move to operational applications through the month of August, through the end of this year, you'll see us substantiating ourselves with reliability, on-road miles driven, and actual real-world testing. And then, of course, they come back, they do what's called freezing it and putting it into production, and then we move to what's called series production, which will be done in our new Calgary facility. Some of our highlight projects, I'm going to go two ends of the spectrum, and I'm going to talk to Linamar since it hasn't been added to this deck. Zero Motorcycles is one of the top electric motorcycles in the market today. We are working with them to provide a higher level of performance, and that project is due end of this month through the first few weeks of next month. It's due out, and it's test bench data that we'll be supplying to Zero. Then we'll work to get the drive installed into the bikes. We have the bikes in our warehouse right now, and those bikes should be on the road for operational validation by the middle of the third quarter. And so actually riding on the road, for those of you in Canada or the US, we'll have bikes on the road in Arizona, and hopefully bikes on the road in Calgary, depending on the weather at that time of year. And then C Electric is the opposite end of the spectrum, where we're working with commercial fleet trucks. Our first project with C Electric is for a Mack LR garbage truck, and that will be delivered in August, kind of early September. And C Electric will put it on the road immediately and do their validational testing and operational testing. And once we move to that, then we can move to series production. Second project with C Electric is called the F59 step-up delivery van, like you'd see for UPS or FedEx, and it will be on a pilot for UPS or FedEx first quarter of next year.
So just to with the Zero, so what exactly are you finishing in the next several weeks with them? And, that's just the bench testing that you're going to finish, and then soon after that, assuming it works well, then it's going to be installed in the bikes. Is there going to be sort of an announcement or any details associated with that'll be announced, like what test efficiencies are gained? Yes. Or whatever metrics?
We won't announce the results of the testing. We'll just announce that the testing has been provided to Zero. It's up to Zero to provide those results. They are a privately held company, so of course we have to watch our NDAs and make sure that we respect our customers' time to evaluate. I'm sure once they finish their evaluation, they'll be happy to co-release with us on their results. So we'll release that we've had successful test results, meaning that from our in-house test bench results have proven to match to our simulations to show the improvement that was requested by the customer, and it's tested with their motor. So Zero has their own in-house patented motor that's in our shop right now, testing alongside our drive. It's on the test bench right now.
Do you have any sense of how many miles or kilometers under driving situations they would need before they give it the final kind of thumbs up and say, yeah, we're good to go and we're ready to launch this commercially?
They haven't given it to us in miles, but they told us it will take about 6 months of in-house testing to get through their process. It's quite rigorous to get through. So the goal with Zero has always been to participate in their 2024 SRSF model. And that means, receiving POs late 2022, early 2023. So there'll be an extensive test period with them. It's an amazing bike with a huge amount of power, that already has a great level of performance. They're already an industry leader, and they're really just doing a great job of serving their customers to get that better user experience.
All right.
And then, of course, our Linamar deal, which we announced late last week, is with a tier one supplier. And Linamar is a supplier to all the major automotive OEMs. And we are co-developing our new e-axle, which means we're providing the power electronics, they're providing the gearing and the mechanical to have a co-developed e-axle system for the electric vehicle industry. And as the project progresses, we'll share more with our shareholders as we can.
As they're a tier one supplier, what, like an e-axle system, they would go to an OEM, a Ford or whatever big name global, and say, hey, we've got a power. Is an e-axle the electric version of what one would call with an ICE engine, like a powertrain, or is?
Yeah, it's some people call them all in one. So it's where the motor, the drive, and the gearbox are all built into one piece, one mechanical unit, versus these applications where we're doing a motor and a drive separately. And in these cases, we're not using a gear on a zero, but on a C, we're using a gear. So it'd be separate. In an e-axle, it's all together. They're pretty popular now in passenger vehicles. They're just entering the commercial vehicle segment. Go ahead.
Are you able to, like with Zero, you said you're hoping to get in the 2024 product launch. Are you able to say with Linamar in what sort of year launch you hope to get the e-axle out?
Yes, we hope to get that out to market by 2023 for series production.
Wow.
We should be validating with them. Yeah, it's an aggressive project. So we are currently, we plan to have it delivered to them by the second quarter of next year as a finished product together with Linamar.
And given that it's a whole sort of combined unit, you have to work really closely with Linamar. Like, are you going to have like a joint development, like a lab where you're working together, or are you going to work kind of remotely and, I don't know, send information back?
Yeah, for now we're working remotely. Our specialty is really power electronics, and Linamar's specialty is in the manufacturing, the gearing, the components, and the supply chain to the automotive. So it's a really nice partnership for us to both leverage our strengths and to work with each other. So for now, we're looking at building the power electronics in our facility in Calgary. There has been a lot of close work with the team. So far, we've been able to do it all remotely, but we'll see how the project progresses, and we're prepared for both.
All right.
And then, of course, beside myself, I have John Meekison, our CFO, who is on the call today, who has 20 plus years experience in capital and small cap markets. Our chief engineer is Eric Hoots, who joins me from International Rectifiers, which is one of the top suppliers to the automotive industry, where he spent over 20 years of his career supplying inverters for the automotive. Josh Sobel, I recruited in November of actually 2 years ago now, as my chief commercial officer, a colleague of mine at GE. Josh was the Siemens segment mining leader for Canada and joined us in November of 2019 as our commercial officer. And Richard Moe was my director of marketing and innovation at GE and then at Wolong, and he joins me now at EXRO to lead our marketing and communications and digital operations. We have a very strong board of directors. Most recently, we've brought on Terrence Johnson, who was the former VP of Audi, Volkswagen, GM, spent over 35 years in automotive sales with tier one automotive manufacturers. And Terrence is based out of Berlin, Germany. And then Julie Wormlinger is the former chief engineer of Ford Motor Companies, where she worked for over 30 years. And she retired in early 2018 and joined our board in July of last year. And we just have a very strong, supportive board that's really doing a lot to help us grow.
Sue, on the board, that's a very impressive board. Are there any pieces that you're missing that you're still looking for someone with XYZ or, I don't know, mining experience or any other sort of missing holes to fill on that board?
I feel pretty good about our board right now. We are looking. Our board's been in the position, with the exception of Julie and Terrence, for the last 3 years. So, like any good small cap company that's growing and emerging, we're taking a look at where that matches up. Probably something from an audit and financial perspective as we grow a little bit more is where John and I would look to. We have good strength with Jill and Eamon for that, but probably somewhere we'd look to grow in the future months.
All right.
And then from a revenue path, how do we make money? That's what everybody always wants to know. Of course, we've got great tech and great people, but how do we make money? We make money through three different areas. Our engineering services, which we're starting to enter into more, where we do partnerships like what we're doing with Linamar, where we develop new products utilizing our tech to make a product that truly has a differentiator to the market. So those engineering services are part of our revenue stream. We have what we call low volume manufacturing, which can be thousands of inverters yearly. And that's done in our Calgary facility, where we're able to produce and supply the product to our customers. We can produce up to 100,000 units per shift. We have a state-of-the-art facility that's being built. We've just received our permits. The facility will be up and running by end of the year and automotive certified in 2022. We are able to have a complete clean room, an SMT line, and supply to any major automotive manufacturer globally. And then, of course, we'll have, as we grow into 2023 and further, these high volume licensing strategic partnerships where it would grow beyond what our facilities could do. And then we'd be looking at either additional facilities that are JVs with partners, or additional facilities that support, or strictly licensing and high volume relationships.
Sorry, just going back to the engineering services. So the work you're doing with Linamar and Zero, you're getting some cost recovery, or you're being able to charge them for the value add you're doing through the engineering services?
On projects like what we're doing with Linamar, yes, because it's a new expansion to our current product line, our standardized product line, in that we're entering into the e-axle market, which we haven't done before. So there's joint development and there's shared cost in that development. With customers like C Electric and Zero, they're using our standard product line that's being customized to their product. So in those situations, the cost is in par work. So with C Electric, for example, they're putting it on the road. They're doing all the on-road validation for the product, which is quite costly, instead of paying a fee up front for design work, because that product's already designed as part of our standard roadmap.
All right.
And then from our financials, we are currently traded on the TSXV. We announced Friday of last week or Thursday of last week that we've received conditional approval to graduate up to the TSX, which we expect in early July. And then on the US side, we're currently traded on the OTCQB. We get asked a lot about NASDAQ, and we'll just say that we've filed our first piece to be able to file for NASDAQ in the second half of this year, but the timing of that is still undetermined, as the executive and the board and I will make a decision for when that is the best time for EXRO. We want to make sure that we're doing it when we all get the most success out of the company for that. We have about 132 million shares outstanding, fully diluted. And just before we go to the Q&A, really, as you think about EXRO, please feel free to reach out at ir@exro.com or to Martin directly. But we really are on a focused mission to change the way the world is looking at energy consumption through innovative power electronics solutions. We've coined the term intelligent electrification, not because our product are smart products, but because we think you need to think intelligently about the transition to electrification. It's not just going to happen because everybody wants to have something that is now electrified. We have to think about that impact on our grid, that impact on our day-to-day, that impact on how it affects our future society and sustainability. And then, of course, this is truly disruptive technology. And with that, Martin, I'm going to open up for questions.